all the gates it's actually seen. The way the tag works, the way the field works, is as you're approaching the infrared beacon and you're wearing this tag, it has a field that extends about 3 meters. As I pass the tag, I can only go for about another meter before I no longer can see that beacon. So I've got a 4-meter region in which I can pick up the tag. The tag can pick up the beacon. And that depends on which way you're walking. If you're walking the other way, the 3 meters extends the other way. So the 3-meter field is the approaching field to the tag. Now, if there are no people in the field, as soon as you cross the threshold, you're picked up by the tag picks up the beacon, and it keeps on saying over that 4 meters, I can see you, 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 and then it says, oops, I can't see you anymore, and now you've left the field. So you get a signal all the way through. When you're in a high-density crowd, unlike the RFID, where the bodies actually block the signal, you can still pick up the signal, but it might be a little bit later. So you won't get it at this point, you get picked up a bit later on. So that's the difference between the RFID and the infrared. When we did the trials in the corridor, and we used even higher density crowds, we used about 23 people, we got 100% pickup. So 100% of the people wearing these tags, even in quite a large crowd, were picked up. And so this is giving us about 100% read rate. So this is what we end up buying. We bought, in the end of the day, we bought 3,000 of these tags. We bought 30 of these beacons. We've got to sort out all the tags. We transported this to the ship. The tags have got to be put into groups. It was a bit labour intensive, but it was a few hours work. We then have to mount the beacons, but you can see because these don't require an external power supply. The battery lasts for about 60 days when it's on. It's a bit of Velcro at the back, and it's very easy to set up. Very, very easy to set up compared to RFID. And you don't have to worry about, oh, is that angle optimal? You don't have to worry about it. You just put it where you want it. Okay, so what you can see here, each of these dots represents where we put a beacon. And what we're going to do with this is we're going to measure the path that the people took, each person through the ship. So on the first, on trial 2, there were 1,349 passengers on board. 106 of those were under the age of 12, and because of our ethics review, we couldn't include those. So there were 1,243 eligible passengers. 1,192 passengers agreed to participate in the trial and took a tag. At the end of the day, about 867 of those passengers who took tags decided to actually participate in the trial. Now, the passengers knew they were going to be involved in a trial, but they didn't know at what time. And so we ran the trial. We set the alarm off at a time that we chose, so the passengers didn't know. And so some of the passengers decided, I don't want to participate. Even though I said I was, and I took a tag, I'm not going to do it, because I'm doing something else. At the end of the day, one of our concerns was we were going to lose these tags. We're going to lose some of these, so lose some of the data. At the end of the 2 days, out of distributing over 2,000 tags, we only lost 13, which was pretty good, so we got a lot of them back. I must stress, though, these were Norwegians and Germans, and so they're pretty trustworthy people who are going to return these things. It's going to be quite interesting to see what happens when we do these trials in other places. We're doing one in Greece, going from Athens to Venice, and we're doing one on a Royal Caribbean in the United States. It'll be interesting to see what happens. Just very quickly to show you some of the results, these are the assembly curves for each of the assembly stations, showing you the number of people approaching. That's the combined curve. The other really neat thing about this, it only takes about an hour of work, and now you have the complete curves, the evacuation curves. It doesn't take days of analysis, it takes about an hour, and you've got this sort of data. What we can also do is construct paths of people. Each one of these lines shows you the path that the person took. So we can construct a very good validation data set, not only knowing which assembly station people went to, starting from what point, what time they arrived, and what path they took to get to the assembly station. So we're going to be able to construct a very high caliber validation data set from this information. I haven't got time to talk about the video stuff, so just in conclusion, 2 assembly trials have been successfully conducted at sea involving 1,769 passengers. An innovative new technology involving an infrared tracking system was used for the first time, and this technology has been shown to be able to track large numbers of people through complex structures, is relatively easy to set up, enables rapid extraction of individual person trajectories. The data from these trials is being used to establish a representative range of response time data for ship evacuation analysis and a comprehensive data set for the validation of ship evacuation models. Work continues with 4 more ship evacuation trials planned using a large cruise ship, this is the colour line, the Royal Caribbean cruise ship, and a large passenger ferry with cabins. This is the Greek ship that we're going to be doing later this year. Once again, a large team of people involved in setting up this experiment and running the experiment, and we had members from all of the partners from the Safeguard project involved in running this, helping us run these experiments. Thank you very much. Time for one question.
What about life jackets? Does that interfere with
No, the passengers on this ship, they don't get life jackets until they get to the assembly station. Okay? On some ships, they have to go back to their cabins and pick up life jackets. And the idea we have there is that you're right, if this was completely blocked by the life jacket, you wouldn't see it. But the idea then is we'll mount this on the life jacket.